what we are going to discuss. Now what we are going to discuss is for mainly valid for non-uniform object. See, this formula is valid for non-uniform object, means of course for uniform also it will give correct answer. But unnecessary, we have to do the calculus part and all those. See, let's take this the object. Okay. This is the object, which is non-uniform. This object is non-uniform. Now this is an object. If it is an object, definitely it is made up of different point masses. Object is what? Collection of all point masses. How many point masses? Infinite point masses. Infinite point masses. Very small. What I'm showing is maybe slightly bigger only. As small as possible. Masses should be as small as possible. What we say in calculus, we have seen so many classes of calculus that if the quantity is very small quantity, what is the representation for that? The representation for them will be dm. Right? Representation is dm. The masses are very, very small. How many masses are there like this? Infinite mass. So we can say that any object is made up of infinite dm masses. Any object is made up of infinite dm masses. Right? And each dm, like dm here, dm here, dm here, will have a different coordinate. Each dm will have different coordinate. So the dm which is located here and the dm which is located here can have different coordinate. So in that case, when we calculate for xcm, if you remember the formula, what we discussed for xcm, we discussed the formula for xcm as for point masses m1 x1 plus m2 x2 plus up to n number of objects, suppose it is mn xn divided by m1 plus m2 plus m3 up to mn, like this. This is for n number of masses. Now we have infinite number of masses. So what we'll write? For each and every coordinate, we can write dm. Okay, mass is dm. What is the coordinate for this? What is the coordinate for this? This coordinate is, let's take x1 for 1 dm. Next, dm into x2. Next, dm into x3. Right? Like this, how many terms will be there? There will be infinite number of terms. Similarly, in denominator, what will write? dm plus dm plus dm plus dm plus dm. How many terms? Infinite number of terms. Right? Which we can write as integration. Now here only you have to understand that how the calculus is changing. Integration is nothing but the summation of infinite number of terms. So this dmx1 plus dmx2 plus dmx3 up to infinite number of term will convert itself into integration. Integration x dm. Remember, for each dm x will be different. That's what the x is inside the integration. It is not a constant. X dependent on dm. So for different dm, x is different. Right? So that's what we are writing, integration x dm by integration d. Now this is how we calculate xcm for any object, including non-uniform object. This is the formula which is absolute formula which has to be used in any scenario. It is valid, but for uniform density we don't have to do it, because for uniform density object it will automatically come using this calculation. Also it will come as a geometrical center. So suppose we'll apply for a rod which is uniform, then it will come automatically at the geometrical center. That we'll discuss also. But it should be used 100% when a density change is there over the rod. If there is some formula of density change given, mass is variable, then definitely we have to use this formula for xcm. Similarly, what will be ycm? Ycm will be integration y dm divided by integration dm. Similarly, what is zcm? Integration of z dm divided by integration of dm. So this is how we calculate using integration if the density is changing formula. Okay. So xcm, x coordinate of the center of mass, y coordinate of the center of mass, z coordinate of the center of mass. As we can see here, it is starting from the very fundamental formula xcm. The difference here is it is infinite number of terms, so it has converted itself into integration. Okay, so this is a formula everyone should remember, so that in the exam it is asked or anywhere it can be useful to you. Okay.